All right. Welcome everybody to week 18, day 1. The project proposals are mostly in. If you haven't submitted your project proposal yet, do that ASAP. I need to look at it and approve it. For example, you might not be aware that putting a box around a face has been done already, in OpenCV. So you need to have something that is scaled appropriately to your group. You don't have to do it in C++. You can do it in Python. It's A-OK. For this project assignment, the only subcategory that has a language mandated is the assembly one. So if you're doing assembly coding, you got to do it in assembly, with helper functions in C++. For everybody else, C++, Python, Java, C#, assembly, anything you want. It's A-OK. It's a project. And so all I care about with projects is your project being super cool and awesome, mostly. So we are going to do the projects will be due at the end of the semester. The end of the semester is next Thursday, basically. So how are you turning them in? I guess I figure I could be here like in normal class time next Thursday, and you guys can just like show off your projects. Does that work? Is today the final review or Thursday? Thursday is the final review. Yeah, and the final, because you guys are going to be working on your final projects, I'm going to make the final like pretty easy for you guys. So a little bit of this, a little bit of that, but nothing hard, I don't think. So I want you guys to be, I know you got finals in other classes too. So you're going to have a couple weeks to work on these projects, and don't let the final like really occupy too much of your mind space. Okay. And so like next Thursday, 12 to 2, show up on Discord, and I'll demo your projects to me. So have I don't know, like be prepared to like share your screen and let me look at it. I want to see chess operating, or I guess for the bridges people, you just send me a link to the bridges thing, I guess. I don't know. But yeah, it'll be a fun goodbye. We've had 4 semesters of computer science together with some of you guys, so it'll be a good chance to say goodbye to everybody. Do data science people have to present? Yeah, sure. Yeah, show us your results. Show me what you got. Okay. All right. So you might not be able to make it depending on the physics test. In that case, then just what did you do, Tran? You were doing bridges. You can just send me the link on bridges. It's fine. Show me what you got. Yeah. It should not be too tough. Okay, so what I'm going to lecture on now is something that I teach every semester, and students always have trouble with it, but it's good. This is our last lecture together. I mean, I guess maybe on the final review we can cover a little more on this, but I just gave this lecture for CSI 41, so Muya might be bored, but such is the life of a TA. All right, so we're going to cover today networking sockets. It's a really important thing to know, and for some reason students just have trouble with it. I don't know. Okay. It's okay. New Destiny season just started. Yeah, networking is really like useful to know how to do. At the end of the day, what you want is just to be able to read and write to the internet the same way you read and write to the keyboard and screen. You know what I mean? It can get a little bit more complicated, because if you're waiting on input from the keyboard and it doesn't arrive, you can always just hit Control-C or something. But if the server doesn't send you anything, then you're stuck. And you know what I mean? Like sometimes like your thing just stops working, and you're like, why did it stop working? And it's because it's waiting on a response from the server, and the server just didn't send anything to you, and so you have to kind of think about these issues. So what I'm going to show you guys first is C networking. C++ does not have a networking library, much to its detriment, in my opinion. Java has a nice networking library. I like Java's. It's verbose, like all things in Java are, and we'll probably look at that next. But I'm going to show you guys, because this is CSI 45, I'm going to show you guys the way we do inner networking in C. So this is a quiz show that I made a while back, and let's see, the name do I? Quiz.c. So if okay, so here's an old code base. Where is main? What Unix command do I use in order to find where main is, where I can start tracing the flow of the program? Easy. What's the name of the command? Make a socket library by hand from scratch in assembly. Grep. Yes, very good. Can't you just compile C or C++ though? Sure, I could. Do I have a make file in here? Yeah, so here's my make file. And you can tell I'm using the MySQL library. And I'm using the math library, and I'm using the libz, which is for compression, and lib new socket library, or something like that. I don't know. Okay, so make clean, make MySQL's not installed on here right now. Well, cool. All right. That's what happens when you update your server. Sudo. What's the command to install SQL? You know? Please install SQL. App cache, search, MySQL. All right. There's a lot of them. All right. So which one's the right one? Apt install package. Very good. Alias please sudo apt. Sudo, let's see, pipe through grep lib MySQL maybe. Okay, so lib MySQL, so default lib MySQL client dev, MySQL data development files, CPP connector for C++, C++ library bindings, lib MySQL client dev. That's probably it. Sudo apt install that. Default lib MySQL client. MySQL++. I don't need these because I'm not doing C++ actually. OCaml, nope. CPP connector, nope. MySQL client system, nope. All right. Sudo apt install MySQL server. And it's actually always MySQL that causes my server upgrades to break for some reason. I don't know why. But what happens is I install MySQL on the server. I then go through the Ubuntu upgrade process every 2 years, and somehow SQL causes the boot on the upgrade to hang, and it won't boot anymore. So, all right. So while that is installing, I can just show you the source code. Look it up on Google. Yeah, that's the other way of doing it. That's the other way of doing it. When you get used to system restart required, not right now. So yeah, when you get used to doing development, you'll see that, like, if you want to install incurses, you'll see there's like all this stuff. Like, I don't even know why this is popping up, right? Yeah. So pipe through grep incurses, and you still see there's a lot of stuff. But what you want to be looking for is something that looks like that. something that starts with lib and ends with dev. That's usually your that's usually what you're looking for when you're installing development packages. They usually end with like -dev. Okay, so grep main star, and we can see that there is a main here in convert. There's a main here in driver. There's a main in process.c. Oof. And there's one in server.c. I'm guessing it's server.c. So then server.c. And so here we have a invalid argument. COC is not happy. Yeah, whatever. I'll just ignore it. So this is a C-style networked server that can handle multiple users at the same time. So the first thing to talk about here is this. So static. What does static mean in the context of a global variable? Static in, like if I put static like here, static int x equals 0. This is a global. Right? So static in this context means that x is a global variable, but it's only accessible within these curly braces. And we can do that to like count how many times a function gets called, right? So every time the function gets called, we, x plus it or whatever. And then that number would just go up and up and up every time it gets called. It's a global with local scope. What does it mean here? It's global already. What does it mean? You know? Between files? Here it means so a file is kind of a weird concept, right? Like we talk about a file, but the more precise way is saying a translation unit is the term you'll see people use a lot, because when you hashtag include things, you're pulling things into this file, right? And so the translation unit is the entire file, with all the includes put in and stuff like that. And so this means it's not actually a global exactly. It is only accessible within this file. So it is static is used in several different ways, as is inline, as is extern. Like all of these things that control linking, it's really one of the more annoying parts of C++. Is that, inline used to mean like, you should inline this. But because inline functions weren't accessible outside of a file, then they end up being, do weak linking on them. So you can have multiple definitions of the same function, and they would all link together properly as long as they're all the same, which they should be. Yeah. So, so what is a file descriptor set? Just based on that name, what do you think a file descriptor set is? And based on the variable name, what do you think this is? Getting vaccinated and watching a lecture at the same time. Congratulations. It's an array of file descriptors. File descriptors for non-blocking I/O, array of IDs, array of FDs. Yeah. So what I'm going to show you guys here is how to have this is the normal way of doing a server, by the way. Like, it's very rare for a server to only work with one client at a time. You know what I mean? And so what this is it's essentially going to be like a data structure you might think of, except C++ doesn't exactly have data structures, but you can think of it as a data structure that basically manages all of the clients connected to it. Okay. All right, so I wrote various wrapper functions to make dealing with networking in C not horrible, I guess. And so I have a wrapper called stir_write, and it writes to a file descriptor. Do you guys remember file descriptors? They're just ints, right? And so if a client socket connection to the server is file descriptor 10, remember standard in, standard out, standard error, right? 0, 1, and 2. But every time you open a connection over the internet, that's also a file descriptor. Everything in Unix is a file descriptor. If you create a pipe between two different programs, that's a file descriptor. Everything, and it's just an int. You know, it's just an int. And so what I have here is a wrapper that I wrote. It's a very simple wrapper, and basically it allows you to write hello world to file descriptor 10, and then hello world will get a file descriptor 10. And it's a wrapper around the write in function, in being how many bytes to write, and so it writes to that file descriptor, that pointer, and this one takes a string length, right? And so I got annoyed at having to write string length over and over again, and so I just put it in automatically. So it calls strlen, sees how big the string is, and then passes that to write in. Where is write in? Let's find out. So wraps.io or writein.c, those both look promising. Here we go. And so this writes in bytes to a file descriptor. And so it takes a file descriptor, takes a void pointer, which means a pointer to any type of thing, and it will write in bytes from that base to that offset, essentially. Size t. Const chars prevent you from modifying the thing that they're pointing at. They can move themselves, but right, like pointer itself can move. It's not a constant in the sense that it can't change. It's a const char star, so it is a pointer to a constant. Okay, and so what that means is you can't do things like say pointer square bracket 0 equals 5. You can't write when you have a const pointer like this. A const pointer means you can read from the memory addresses, but you can't write to it. Do you guys understand? I think I might not have gone over that too much in CSI 41. There's like 8 different meanings of the word const. And so, do you guys understand this though? Like, when you have a const void pointer? C++ doesn't like void pointers very much, by the way. C++ has different ways of doing polymorphism. In C, it's just like there's no type. It's just a memory address. It's got no type. Who knows what it is? You know, we're just gonna be writing bytes, man. Are you guys still here? You're listening? Paying attention? Yeah. This makes sense to you? Like this takes a memory address. That's what and it can read from the memory address, but it can't write to the memory address. You guys with me? Like that's what that means. Okay. And so it duplicates the pointer, and then it sets n left equal to n. I probably could have just done that up here. While n left is greater than 0, if n equals right less than 0, if an error occurred, then it didn't write anything. It tries it again. So what this is doing here, it's going to repeatedly call the write system call. Right? You remember how I was telling you guys about the read, the write system calls and things like that for that assembly assignment a while back? The system call, you give it a file descriptor, a pointer, and how many bytes to write, and it will return how many bytes are actually written. And so if if it was successful, like let's say you have 1,000 bytes to write and it wrote 100 of them, because when you're doing networking, you can only write a certain amount at a time. Then it returns 100 were written, so it decrements 100 from how many bytes are left to write. It moves the pointer forward by 100, and then it keeps retrying over and over again. If a network burps, then it says, okay, I didn't write anything, and it tries again. For any other error, then it bails out. Okay, so what this does, it'll repeatedly call the write system call over and over again until the buffer of stuff to send is empty. So that is a and then there is a capital write in over it. And basically that's a wrapper. So write in writes in bytes, and it will retry and things like that over and over again. And so write in is sort of a wrapper around write, and then capital write in is a wrapper around write in, lowercase write in, which simply says that if an error occurs, it calls this error function that logs that something bad happened, things like that. And then coming back into here, we have a wrapper around the capital write in, and all of these things are abstracting away and trying to make it simpler and simpler and simpler, so that at the end of the day you could write code that just looks like this: stir write to file descriptor 10, hello world. That's basically parentheses. This is all it takes to send something over the network. And so where does this come from? I'll show you in a second. So likewise, I have a wrapper that I wrote called disconnect client. You pass in a file descriptor 10, whatever. And then it has this array of connections. This is a global, probably up in here somewhere. I've got an array of all the different connections, and we close the socket. So this is, again, if you see a capital C, that means it's a wrapper around lower level stuff. Because even when you're working in C, you don't want to work with this super low level syscall stuff. We typically wrap it and wrap it and wrap it to make it really nice and easy to use. And so I'm just going to pass in, 10 or whatever, close 10, and that shuts down the network connection nicely. If you don't call this, the socket will be left in a dangling state, and it takes 5 minutes for the system, the operating system, to close it. So you always want to be careful to close all of your sockets, because there could always be network in transit. And so if you just sort of like shut down the server without closing the things, then the sockets will be left open for 5 minutes, and you can't rerun your server, among other things. So we clear that person out of the array, and I keep track of what state each of the clients is in. So I have a state machine that basically, when people connect, they go from state none to state authenticating. Once they've authenticated, then it puts them into a different state of like ready to begin quiz. When they send the begin quiz thing, then I put them into the quiz begin state, so on and so forth. Here is my, well, okay. Yeah, that'll actually show you where these numbers come from. Okay, so connect client, constant pointer but put together. Yeah. So const pointers are it's like a const reference in C++, where you want to pass something by pointer, but you don't want to be able to change it. Okay, so this is one of the 3 big functions for doing networking. So accept is how a server gets connected to by a client. So the server will sit there with, it'll listen, and it'll maybe we should go over the terminology a little bit. Yeah. So you first listen and then you accept. Okay. And then what basically happens is we have that connections data structure that I was telling you about before. So we call pselect on it, and pselect tells us if there's any sockets that are ready to send stuff. If somebody's trying to connect to us, we call the connect client thing. Otherwise, we basically just go through and handle each one of the sockets that's ready to read. And so if we've got 1,000 sockets, we can select which ones are have data this frame. The server runs over and over again, and it'll read data from them. It'll parse it. There it is, and then try it. And so it'll base. So if you've got 50 people all connected to the server at once, then it'll sort of highlight which of the sockets have data available. It goes through all of them, pulls the data out of them, parses the packets. This is where the heart of my program is. It's inside of that function there. That's the actual heart of the thing. All the rest of the stuff is just setting up a networked server. So let's go into OneNote. Let me show you guys what this looks like. And this is why with my CSI 41 students, I'm doing networking in Java instead, because that's kind of garbage. All right, so you guys have all used the internet before, right? Perhaps, okay. Well, so the internet is also known as the information superhighway. Most of these things work on what's called a server client basis. Right? And so if you want to connect to a server, like let's say you launch PuTTY, right? There is an SSH server out on the internet somewhere. You want to connect to it. So you need two things to connect to a server. You need the host name, like let's say csci4x.com. You need a port number, port 22. Okay? And the port is important because this server could be running other services as well. It could be running an HTTPD server, which would be listening on port 80. It could be running FTP on port 21. There's a lot of different named ports that you can't just like use, and those are all usually below 1024 usually. If you want to run a Quake server, that runs on port 27500. 27500 is the port for Quake. Yeah, so you've got this, and then so the server can actually have different services available, right? It might have like HTTP and FTP and SSH, right? SSH is port 22, port 21, port 80. And so the client has to specify both the host name, www.csci4x.com, and it has to specify a port number. Okay? When it does that, it connects to the server. Now, what happens? So the client is going to call connect. Step one, connect. The server, step one for the server is it calls listen. So listen basically says listen on port 22 or whatever. Listen on port 22. And so what that does, it just creates a socket that's open, and it can then accept. It can then accept new connections on that socket. So you first say, I'm listening on socket 22. It doesn't do anything in and of itself. It just opens the port, ready for taking new clients. The client calls connect. They call accept, and accept will send back like you're accepted. And then I don't know, you're good to go. That's it. That's the whole process of connecting to a server. So on the client side of things, you just call connect, and on the server side of things, the first thing you do when you first boot up your server is called listen. So listen basically opens up whatever port you've picked. I pick port, I don't think it's actually in there. I think it's a command line parameter maybe? Nope, no. I pick port 2001 for whatever reason. So this here is, so, again, anytime you see anything with a capital S, that means it's a wrapper around it to make it nicer. So I can show you the lower level details if you want. But basically what this is saying is I'm creating an internet socket, and it's a streaming socket, and I don't know what that means. And B0 mem blanks the whole thing, but this is a server address. There. So that is a struct, and it's a C-style struct, and so this is just setting everything to 0. And then we set its family to be internet, because this would, the C sockets library predates the internet as such. We then say we will accept connections from any address. We're listening on port 2001. If the user specifies a command line parameter like server 2010, then it will convert 2010 from a string to an integer, ASCII to integer, converts from a string to an integer, and then calls host to network short. What is host to network short? Is that how you blacklist? No authorization or authentication? That comes later. By default, it accepts connections from anyone, and then they have to authenticate after they connect. But yeah, you can, by default, it just accepts from anyone. What is host to network short? I'm going to pause the stream here because I think my coffee arrived. So discuss amongst yourselves and see when did we talk about host to network short byte ordering for the internet. I'll be right back. All right, I'm back with my coffee. Let's see if you guys got the right answer. Big, yes. Big and little Indian, exactly. So Intel machines are little Indian. Motorola machines are big Indian. ARM is bi-Indian. It can be booted up in either system. It's usually invisible because the way that the bytes are ordered in RAM usually doesn't matter. It does matter though when you push it out over the internet. So everybody in the internet has to use network standard byte ordering, which is big Indian. Okay. So anytime you do anything with the internet, you always have to call host to network short to translate from your byte format to the internet's byte format. Host to network long for a long number, host to network short for a short number. And then when you receive things from the internet, you do it the other way. You say network to host long, network to host short, that kind of stuff. And the reason for that is because the internet is standardized around big Indian. And now, if you're on a big Indian machine, you could actually get away with not doing this. However, if you then took your source code and ran it on an Intel machine, everything would explode, right? And so you just always do it, you know? You always do it. Okay. So it defaults to 2001, but the user can when you run it, you can specify a different port if you want. Bind, it basically binds the file descriptor we created here. So this creates a new socket, and remember, a socket's just a file descriptor. That's all it is. As of right now, it's without form and void, right? This is just a socket with no presence on the internet at all. It's just a file descriptor. It just creates a file descriptor. And then binding it turns it, gives it shape, right? So this file descriptor here, you pass in the serve adder. Basically, these are the options. And so you're saying this file descriptor is going to be on this port. It's going to talk to anybody. It's using the internet, and you pass in, of course, the size of the struct because it's C. So that sets the options on the socket, and then you go boom, listen. And so listen opens up that port. So we're saying this socket, this file descriptor we created begin listening. And so that opens the port 2001, let's say, and then it's ready to accept connections from people. Without that listen, if clients tried connecting to it, they'd get an error connection refused. The server by default doesn't allow connections on any port, only those that are explicitly opened. If you are not root, you cannot, or to put it another way, root can open up sockets below 1024. Users can open up sockets above 1024. Okay, so you can't open port 80 if you're a normal unprivileged user. I mean, root could do 10,000 too if it wanted, but in general, system ports are the ones below 1024, and user ports are the ones above that. And so, what if somebody else in the server was currently running a server on port 2001? I couldn't do it. It would die. So I'd get an error and damn, no. I mean, since I have root, I could just find who has port 2001 open and kill their thing and then run my own. But that's why you have to specify what port. You give the option of specifying port in case somebody else is using the port you want already. Okay, so this is a data structure that is used to hold all of the different connections, which are just file descriptors, which are just ints, basically. And so malloc is new. That's the C version of new. That will new memory. And we set up a timeout value for timing out. If we try reading from something after 2 seconds, it'll fail. Yeah, and then basically all this stuff is how you basically look at a set of, like, if you've got 1,000 people connected, you want to know who's transmitting at the time. And this is all very C-like things. These things are macros, by the way. So these are hashtag defined things. But yeah, if the listen file descriptor has activity on it, so it's like a bit field, I guess. And so it'll set to be true, if 50 is active right now. So if you get a connection, if you get an incoming connection on the listen file descriptor, then it calls connect client. And so connect client does the accept up here. You call accept. And then what that does is that actually makes the connection. So the client tries connecting to the server. The server has to be listening already. So the server does listen, the client connects to it, and then the server does accept. And then that establishes the connection. And it'll print to the screen, client is connected from their whatever address, IP address will print. And then it goes through the array of all the different file descriptors, finds an open one, and writes the file descriptor into there. So this is an order in process, probably not the best way of doing it, right? But whatever. Even for 1,000 clients, like, it's fast enough. If I was scaling up higher than that, then I'd definitely do something else. But what this is just I keep track of who the highest file descriptor is, so that if I have if my array has 1,000 spots in it, and I know I've only got 10 clients, then file descriptor max is going to be 10. And so if client 11 connects, then file descriptor max goes up. So anytime I iterate across all the clients, I only have to go up to the maximum one. And it will pack the array. If somebody disconnects and then somebody new reconnects, it finds this thing here, finds the nearest open spot and puts the file descriptor in there. Make the socket non-blocking. If this looks like garbage to you, yeah, it's fair. And then we write, okay, so this is my code. So like I said, when somebody first connects to the server, they're in the no connection state. Once they connect, I put them into the auth state. So I have a state machine that basically keeps track of what state each socket's in. And so we just print, and this is how easy it is to send. That's printing something over the internet. So writing to this file descriptor, write the string, welcome to the server, please enter your username and password, or whatever it is. Okay. Where did the connection file descriptor come from? Client 10. Well, that came from accept. So accept returns a new file descriptor. Okay, so coming back over here, there's really just three things. There's listen, which opens a port. Which opens a port on the server, so it's ready to accept. There is accept, returns the file descriptor of the connection to client. Okay, so you first call listen, and then we call accept. Accept returns, congratulations, there's a new file descriptor. It's file descriptor 20, and then you just read and write to file descriptor 20, just as if you were reading and writing to a file on disk. That's how easy it is. And we're doing C here, so everything looks like low level garbage kind of, but that's basically the story. All this kind of stuff with like maintaining, like this is all necessary because we have multiple file descriptors, and so we scan over them to see which ones are ready to read and write to. At the end of the day, we can use stir write to write a string to a file descriptor. We use network read to read from the network connection. That's it. So stir write prints a string to them. Network read reads data from the client. And once we've read the data from the client over the interwebs, we call parse packet, and that's my actual okay, it's still in server. Let's see. And this is my actual code. So this is the actual server. So it's a quiz show. So people connect, and I parse the packet they send to me. So I pull the first 3 characters out, and basically what I did was I created a protocol from my own client to my own server that was fairly network efficient and things like that. And so I do things like pull the first couple bytes out, convert those bytes from ASCII to an integer, and the control code is basically what kind of packet is this. And so the client will send something like 42, which means authenticate me, or 690, disconnect, or whatever, And so I just wrote down on a piece of paper all the different control codes, and the client will send to the server what kind of packet I'm sending you. Am I sending you a quiz response? Am I sending you an authentication packet? And then, so what I did is I just pulled the first 3 bytes out of the packet, and set the 3rd byte to be null character so that I could call A to Y on it. So that converts the first 3, so 0, 1, and 2 are, it's a 3-digit number. So it converts that into a number. I printed the screen just to make sure it works, sometimes. And then this is actually kind of clever. So do you guys know what that's doing there? What is that? This is welcome to SeaWorld. Welcome to SeaWorld. What is that? Read buff is a just a string, I think. Yeah, read buff is just a string. It's just the string that was just sent to us over the internet by a client, and now we're gonna parse it. Okay. So the first thing I did was I grabbed the first 3 bytes out of it and turned those first 3 bytes, like 1, 2, 3, whatever, into a number. That's how I know what kind of packet they're sending me. What is that? It's like a job interview question. Yeah, so Rivera had it correct. What this is doing is read buff character 4, 0, 1, 2, 3 have already been essentially pulled out and processed. 4, and it takes the memory address of it. So it's the beginning of the second part of the string. And so data string is just, should be a string also, right? Char star. Yeah, so it's just a string that I'm just doing a little pointer stuff here. So I've got, like, let's say that they're doing an authentication packet. So they send in code 11 for authenticate, and then they pass in their username, and then, okay. And so what we want is to split this into two things. First is the control code. The second is their username. And so this part here grabs the first 3 characters out, turns it into the control code, and then I do pointer tricks to get the memory address of the 4th element of the array, and I take that as the start of my string. And so basically I just treat data string as the rest of the string, and it will print, so it'll print the control code, it'll print the data string, and that is all it takes to parse the thing. Every packet they send over is a control code and a string. That's it. So if the user has not authenticated yet, then the only kind of packet I accept is authentication packets. If they're normal and they try authenticating, then if they try authenticating after they're already authenticated, I write them a sternly awarded letter. If they try doing an administrative, because I have administrative codes as well, so when I connect to the server, I can do things like create students and things like that. And so if they are not, if they don't have admin permissions and they try doing any of the control codes in the admin range of numbers, then it will yell at them as well. Okay. And so, oh, look, a switch. Okay, so if it's an authentication thing, then we do SQL database stuff. So when they send us a authenticate packet, we take the data string right here. We take the data string and we does that actually do the authentication? It might. And so basically, I think this is actually what's going to connect to the SQL database. No, okay. This is the actual authentication. Okay. So it does a SQL query, and this is kind of bad. This is kind of bad. You really shouldn't do this, but you should use what's called a stored procedure instead. However, I do actually do a pretty good job sanitizing the input, so you can't do a SQL injection attack here on me. So the thing, I think Authenticate splits this into the different parts, like the client name or something. I don't know. It's been a while since I've looked at this code, but anyhow, so what it does is it grabs the user. Okay, so we connect to the database, and then we do a query, and like that. We do a database query, get the result. If there were no hits, then session client equals 1. Otherwise, that. Okay. So 100, right? Max sessions. Okay. So basically, this it's gonna pull from the database their username and password, and basically check to make sure the name and password they passed in was correct. And if it is, congratulations, you're good. We limit the number of people, max sessions, to be 100, I guess. And so if we're over the limit, then we say, sorry, server's busy. And then if they authenticate properly, then we send them a message saying, you're, send to that file descriptor, welcome to the quiz, ready to begin, when you are. And we move the state machine over to the stopped state. They can create a new user. So they can create a new user, they can get their password mailed to them, they can start the quiz, and that begins the quiz. And then when that happens, it queries the database, grabs quiz, like they'll say, give me quiz number 42. And then this does a SQL query. Again, this should be a stored procedure rather than just hard coding it. But like I said, I do a pretty good job scrubbing everything, so you can't do a Bobby Tables attack on me. And so basically, this will send a string to the SQL database running on the server, and it'll say select star from quiz metadata where quiz ID equals 42. There should only be one result, right? And so we do a query. If the result is not found, then we write back to them, sorry, couldn't find the quiz, or no, actually, we just default to quiz 0. So if there's if they couldn't find the quiz, it just defaults to quiz 0. You get the default quiz, I guess. And then we move them into the playing state and begin the quiz session with them. Okay. I think there's somebody at my door. There, right there. So this is what SeaWorld looks like. It's a lot of macros, a lot of pointers, things like that. The takeaway out of this, there's a couple takeaways. First of all, just the process of doing a listen and an accept. And it gives you a file descriptor, and then you can read and write to that file descriptor like you read and write to a local file. That's the basics of networking. Is it at the end of the day, when everything's set up, you're given a file descriptor, and you can read from it, and you can write to it. That's it. And I have these things set up to do non-blocking I/O. So if you try reading from it and there's nothing there, it just times out and moves on with its life. So it won't freeze. The server won't hang. And non-blocking is up here somewhere. So the first thing I would do if I was in your shoes and wanting to make like a networked client server game or something like that, is I would just start off with the basics. Start off with listen and accept, read and write to a single client. And then after that, allow multiple clients. So have an array of file descriptors like I do, or do multi-threading, which is probably a better way of doing it. And then maybe have a shared data structure. But when you do that, when you have a shared data structure, if you're doing the threads, then you have to start getting to thread safety issues and concurrency and mutexes and things like that. If you do it single-threaded, which is what this is a single-threaded server that simply looks at the set of file descriptors and sees which ones are active this time and reads from those and parses those and ignores the rest. Then you don't need to worry about concurrent data structures and things like that. But basically, you just have the server have some sort of data structure in memory, keeping track of who's connected and what their scores are and things like that. I actually offload all of that to MySQL. So my thing will instead, when they connect, it will authenticate them using MySQL. So my server itself doesn't really have any data structures in it other than just maintaining that array of file descriptors. Everything else just offloads to a database. So when they connect, it says, hey, here's their username and password. Do they exist? And it'll be like, yes or no. If they create a new account, then it passes that on to... I think I might have actually offloaded that to a website, so teachers would actually, I think, create accounts for their students. I think I might have disabled that at a certain point, but one way or another, it can create accounts on this website, and it makes accounts for all the students. Username and password are made there, and then the students can connect using the quiz show and things like that. I believe teachers can make their own quizzes as well, and then you could have everybody in your computer lab launch the quiz and take it together, and it gives you scores and things like that. So so the second big thing here is just these MySQL bindings. So the binding between C and MySQL. and how you pass a query to them. So a query is just a string here. Like I said, there's a better way of doing this called stored procedures, but like I said, this works fine. It's not exactly a high performance application. You know, student clicks on one quiz question every couple seconds, maybe. You know, and there's a client limit of 100. Like, it's not. I never ran any performance issues with it. I ran fine. So, yeah. So if you guys want to do real programming, tying your code into a database is really nice. So that way you don't have to make your own files and like parse your own files and keep, you know, no, I just offload all that stuff to SQL. All the user data is in there. All the quiz results are in there. Every time they answer a question, it goes into the database. And I just let the database handle it. And so that means, yeah, my database has hundreds of thousands of answers. 1 second. All right, plumber just left. Had a leaking toilet. There's like a lot of silence on Discord right now. So, if I was in your shoes and wanting to learn this, I would start small. Start at the very smallest and just start layering things on top of each other. You know, there's two big different things here. One is networking, and the other is connecting to a database. And the MySQL C bindings are pretty simple. You call MySQL init, MySQL real connect, logs into the server. It passes in the username, password, database, some other options, localhost. So this is actually making a network connection to the SQL database. It could be local, it could be remote. This would actually work fine if the database wasn't hosted on the local host. I would just have to change that. So it logs into an authentication server, and if the password doesn't work or whatever, it'll error out and die. Otherwise, it pulls it. You guys know sprintf, right? So this is string printf. It's like a string stream. So it's putting a string into a string, but putting the number in here. Then it does MySQL real query. So it passes this query over to the database. So that's the database, which was initialized here. Inside of C, you typically have to call an init function, and oftentimes like a close function as well. There's no constructors and destructors in C, and so you explicitly have to call a constructor, which they usually call initializers. And you typically have to call a destructor, which is usually some form of free or close or something like that. So this initializes some data structure. This connects the data structure to the actual database in real life. This one passes the query to it. This gets the result of the query. So all of these things just keep passing in a pointer to, see how this is in C world? Everything is just passed by pointer, right? And this, you pass a pointer to the SQL database and it gets the results, and then you can do things with the results if results are null or whatever. Then, sorry, couldn't find it. Then it frees the results. Again, you have to call free after you call something, right? So this is going to new memory, and so you have to remember to free it, and then close the connection. And that is what things look like in C. In C, you explicitly call inits, and then when you're done with things, you have to explicitly call the frees and the closes, and if you don't, you memory leak. And if you're not supposed to, then you crash, and that's why C++, especially with smart pointers, is so much nicer. Okay, there's just like dead silence on the Discord right now. So let me show you a nicer way of doing it, I guess. All right. Show you a nicer way of doing it. All right. Echo. Let's go with Java. Java is honestly far more easy to do sockets programming in than C or C++. And I repeat myself, because C++ doesn't have a networking library. you would still be using all of that garbage C stuff, and it's not garbage. Like it works fine. You know, it's just it looks hideous. Java is gross. I don't know. You tell me. So here is a Java Echo server. So this is what I said. Like whenever you start doing networking stuff, and I highly recommend you guys learn this because the internet's a thing these days, you know, and I hear people use it. And so being able to read and write data over the internet makes you a much, much more valuable programmer, right? If you can do things that operate on the internet, that makes you much, much more valuable as a programmer. So here is networking in Java. So in Java, everything's inside of a class, right? This is the Echo server class, and it's got a static, which means it's tied to the class, not with an object, called main. You pass in a command line parameter for which port number it will be operating on. So you'd say Java Echo server 2020 or whatever. That parses the first command line parameter, and then that is how you open up a ServerSocket. So you open up a ServerSocket just passing in the port number. That's it. You don't have all these IF, INET, host adder, any kinds of things. It just, all the defaults are the defaults. All you do is say open up new server. It's very verbose, right? Like you can see they split it over 2 lines because even just making a single socket, even though it's one option, it's still Java and it's really long. So this is just going to say, you know, basically listen on, this is the listen, right? Okay. So that's going to start listening, and then we call accept. And so accept blocks until a client connects to us. Cool. So we can do System.out.println. Server is listening on port. Server's listening. Blocking accept, and then we can so you launch the server, it's going to sit there, it opens up a listening port, and then it just waits for somebody to connect to it. Somebody connects, prints out client connected. This library comes with Java by default. Yep, it's part of the standard library and has been for 24 years. C++, we have to make sure we're going to do it right. How many millions of people have lived and died since the internet became a thing in '95? It existed before then, but that was when it really took off. Yeah, millions of people have lived and died, and C++ was like, well, I still have to study this and make sure we do it right. Just copy Java, my lord. Not too bad. Out of the box networking. Yeah, it's nice. Why is it doing this twice? It's redundant. Seems redundant to me. Port number. Why go to the effort of doing this if I'm not going to use it? Okay, makes it a little less. Makes it a little less verbose. Okay, and then that accepts. So when that will sit there and wait, somebody connects, it'll print clients connected. Now, here is the Java equivalent of what I just showed you. You remember how I was using read and write the system calls? You read and write, just take a file descriptor, and you can read and write to standard in, standard out, standard error, a file, or a network, and it's all the same. It's all the same. This is the Java equivalent to it. So it is verbose because, of course, it is. It's Java. They have, you know, why type 10 letters when 100 will do? You know, And so what this is doing, it's getting the output stream of the client socket and wrapping it into what's called a print writer. And then this one is turning the input stream and wrapping it in a buffered reader. Anyhow, so the point is that we're given a variable named out and a variable named in. And you can read from in, and you can write to out, and it works just like reading and writing to System.out. So you can do System.out println or out println. Out is the socket. Maybe it shouldn't be called that. I don't know. Socket out, maybe. Maybe that. I don't know. Maybe, is that more readable? I don't know. Okay, so that's it. That's the entire program. Okay, so let's go through this. So once you've got socket out and socket in, you just read from them, you just write to them. That's it. That's it. The only thing you have to be careful of is if they disconnect the read line. You notice how this is their main loop now. So what it's doing, it's waiting for the client to type a line. Once they type a line like hello, hit return, then input line gets set to be hello. You know. However, if that fails, if the socket closes, like the user quits their program or whatever, it'll return null. And so if they return null, it bails out. We're done. And the server actually quits at that point, right? The server actually will go away. So when the client disconnects, the server goes away. It's a very bad design for a server, but this is the basics, right? And so I added this, so it's going to print to the screen, read from the client the string they typed in, and then it will print back to them the line they typed in. You can see server echoes back, and so we're going to read. We basically, this thing is set up to read one line from the client, and then it prints it to the screen locally, and then it sends back over the internet. Server echoes back that, or we can do something cool, like we could reverse the string or something. I don't know, but that's it. That's not working. Okay. It would close the server if even if other clients were connected. There can't be any other clients. This isn't in a loop, right? That's on a while loop, right? There's no for loop. There's no while loop. It accepts one client, and when they quit, it quits the server. So, if you wanted, you could put it into a loop or something, but yeah, that's the next step is handling multiple people. But whenever you do networking, always start simple. And whenever you do anything, just start simple, right? And so this is yeah, it'll just sit there and read something from the client and then just echo it back to them. We've got a try catch block here, so if something goes wrong, it prints it, and that's it. That's a server. I don't know. Like, I know Muller doesn't like Java, but I don't know. I mean, this is obviously much less complicated. The other thing was actually software that I used for like 7 years, and I tested thousands of students and had probably hundreds of thousands of quiz responses. And at the end of the year, what I do is I do a SQL query that would grab all of their responses, like from a district, right? So grab everybody in Fresno County, and because I worked with Fresno County for like 8 years doing history testing and things like that, and I would grab all of the responses, see if they were correct, see if they're wrong, aggregate the data together by classroom, by teacher, aggregate them together by school, aggregate them together by district, aggregate them together across the program, all the districts, because we had all the districts in Fresno and Madera and Tulare counties, something like that, and then compare them against the control groups. And so we would do classroom level, school level, district level, site or program level comparisons, different levels of, and then by grade level, 5th, 8th, and 11th, and I don't know, other disaggregate, other slices as well. And we compare them against the control groups. We paid teachers money to just test their students, not part of the grant in any way. And we would do a baseline test, and then we would do an end of the year test and see if the people in the program did better over time than people in the control group, and then ran t-tests and ANOVA and all this other stuff, basically to say, was the program effective at making better teachers? That was the question. Data science, right? Was the approach taken by this 5-year, $5 million grant given by the United States Department of Education, Teaching American History, program, was that money worth it? The U.S. government spent $5 million. In exchange, it got this much improvement in test performance in U.S. history on a standardized U.S. history test. So, good news was our program was successful. It actually did show statistically significant gains. I don't know how you put a price tag on students doing 15% better than their peers. Was it worth $5 million? I don't know. That's a judgment call. I can't make judgment calls. But at least it worked, whereas most of the grants didn't show any improvement whatsoever. So ZMQ, yeah. ZMQ is an even simpler way of doing this, but for some reason students couldn't get ZMQ, so I don't know. Okay, so let's look at what the client looks like, because we didn't look at the client for the other one, because the client was not actually written in C. For the quiz show server, I had a Java client connecting to a C server, and that works fine because it's networking. It's A-okay. And so the Java client would have a graphical user interface with mountains, with buttons you can click on, and score and sound effects and things like that. So it was a user-friendly thing. They didn't have to look at scary text like this. Okay, so let's look at the client and see what it looks like to be a client. Squeak, 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 squeak. So for the client, you have to pass in 2 command line parameters. First of all, which IP address you're going to connect to, and second, which port on that IP address you're going to connect to. So it parses the, this is like argv and argc in C, C++. Java does it using an array of strings, which to me is better than how C++ does it. C++ still does, int argc char star argv. Oh, thanks. Give me a string class. So that is the host name, which will probably be localhost, and this is going to parse, the number into a number. So here we go. So here's the client. So we just call new socket, pass in the IP address and the port number. That's it. That's it. And it connects. That's it. That's it. You notice how I didn't have to call like connect on it? Because the constructor does that for you. If you pass in an IP address and a port, it connects for you. Boop. There you go. It's connected to the server now. Cool. Neat. And then again, it pulls out of the socket the output stream and the input stream and wraps them in different things. These are called decorators. With Java, you can composite classes together out of other classes, and for buffered reader, it improves performance, for example, if you do it that way. I'll call this socket out and socket in again, just to make it clear that it's not the system in and system out. And so their code actually wraps the system in. That's the keyboard. That's standard in right here. That standard in gets wrapped up as well and just gets called standard in. I'm going to be funny and call it cin. So why not? Okay, so try. Okay. Okay. So again, this is our main loop. This is our main loop here. So we're going to read from the keyboard one line at a time, and if the user hits Control C or Control D is end of file, right? Then we get a null. And basically what it's going to do, it's going to read a line at a time. It prints it to the screen. You just typed. And then it is going to receive from server. Wait. When do we ever send it to the server? Did I delete something? So this is going to read a line from the server, but when do we actually write anything to the server? Oh, out. Okay, sorry. Yeah, so that out, that's why I don't like it being called out. Socket out. Thank you. So socket out is going to send to the server the string we just typed in, and then we are going to. So we read a line from the keyboard, we send it over to the server, then we read a line from the server, and we write back what they sent to us. Okay. And then there's different exceptions that get caught, and that's the whole thing. Okay. All right, so let's compile this. Java compile echo star. Why not? Okay. You don't like it? Ah, fine. Start that Java. Try with resources. Must use System.out. 16. Wait, is that on server? Yeah. Echo server.java line 18 and 16. Oh, all right. Can't do that because it's part of the try block. Fine. Here, system.out.println client connected. Cannot find symbol. All right. Then echo client.java line 24. So socket in. Okay. Because there's system out and there, I don't like using out when there's system out, you know, like it's a little confusing. Or in when there's system in. So I rename these things to be socket out and socket in so you can make it a little more clear that we're reading and writing to a socket here. Okay, now let's go back over here. SQL's installed now. Okay, so cd sockets. Okay, Java server port 9000. Echo server. Okay, and then we will run over here. Java echo client localhost port 9000. So the server just wrote out client connected. Hi. So we sent hi over the network. Read from client. Hi. Received from the server. Server echoes back. Hi. Okay. Bye. Okay. So there you go. Now, do you guys want to see how to handle multiple people on a server before we finish for today? So I'm just going to leave echo client alone because it's good enough. And you notice when I disconnected here, the server quit, which you don't want to have. World of Warcraft, somebody disconnects. All right, server's dead. Yeah. Okay. So I can push out all the source code to you. You're not going to get a networking assignment this year. Last year I gave it, and literally nobody turned it in. Harlan probably got the closest to getting it to work right, and even he worked really hard on it and didn't get it to work. I don't know. Doesn't seem too bad to me, but you know, such is life. So I remember working on it with him. Yeah. That was ZMQ. Battle Sloop. Yeah, it was ZMQ. Mm-hmm. Which one? What was the name of that? Battle Sloop. Battle Sloop 41. Was that it? Network demo. Yeah. Okay. So, okay, here is networking in C++ using ZMQ. And so, so it reads a string from a socket. And it splits it by colons. So this is doing a parsing like I had before. And it has a command, log in, log out, whatever. And what it's going to do is the client submits a string with username and command and then a string. And then it reads a string from them and then it writes it to them here. And it's basically a chat server as well. So it's using something called ZMQ. And I don't know, to me it's pretty easy to use, but like I said, Harlan worked pretty hard on it. Couldn't get it to work. Make sudo apt install ZMQ dev libzmq dev apt dash search ZMQ pipe through grep lib czmq ZMQ pp dev. All right. Linker errors, right? Linker errors. How about that? There's something else I need to install. Installed, yeah, whatever. So sockets. There's also sockets doing boost. I've actually put together demo code for a lot of different ways of doing networking. So boost ASIO is considered the standard way of doing C++ networking. ZMQ is pretty popular too. Let me just show you Java again. So if we've got a if you want to do a multi-server.java, then this is the standard Java way of doing it. There's probably better ways of doing it, but this is the standard way of doing it. So what's going on here? What's going on here is the we run the server, and so the server creates a new ServerSocket. So that's the listen, right? We're going to listen on port 9000. And then while listening is true, it can't ever not be true, so it's a bit weird. I don't know. While listening is true, we create a new thread. Okay, so this is a way of doing what's called multi-threaded servers. So every time a client connects, see how the accept is buried in the middle here. So every time a new client connects to it, accept blocks until somebody connects. So once somebody connects to the server, accept returns. It passes the socket returned by this to this new class, which I'll jump into in a second. And it is a thread. It inherits from the thread class. And so the thread class, unlike in Java, unlike in C++, it doesn't run immediately. So you call start on it. And then that launches a new server thread. And then that server thread will talk to the client. The only downside is there's absolutely no interaction with any of the other threads. So every client that connects just gets its own thread, and there's no multiplayer, right? So that would be the next thing to add on top of that. So what does a multi-server thread look like? Server thread looks like this. So extends, so it's extending from the thread class. Multi-single player, yeah, really. And so the next step would be putting together like a concurrent hash map or something like that, so that the things can talk to each other. The trouble is with threads, whenever you're reading and writing to the same variables, they can smash each other. And so you have to be very careful to have thread safety. Java has a keyword in it called synchronized, where you can add synchronized to a function or something like that, and that generates an automatic mutex for it. So if you have a function call and you only want one thread to be in at a time, you can just toss the synchronized keyword on there and it generates an automatic mutex for it. And if one thread's inside of it and another thread tries coming in, it stops. Once the other person leaves, then the other thread comes in. It's a really nice language feature. I like it a lot. It's oftentimes not exactly what you want, and there's more fine-grained ways of doing mutexes and things like that. But if you just have a simple like logging function where you're just going to log something to a file, yeah, it's slap synchronized on it. Only one person can be writing to the log file at a time. You don't have to, go with a mutex and a lock guard and all that other stuff. It's pretty nice. Sounds like No Man's Sky. It's fine. Okay, so here we are. When run begins, it creates the out and the in, just like before. So it turns the out and the in into socket out and socket in. And again, I'm just going to rename them because I don't like out and in as names. When you connect to the server, it spawns a new thread. The thread does the exact same thing we were doing before with an output and an input. You can just read and write to them like reading and writing to the screen. Easy. The knock knock protocol is the heart of the program. It reads, knock knock, who's there? It goes through that whole thing with them. And it basically prints to the socket the knock knock protocol. Will feed you a line, and you basically send that over the network. So it'll be like, knock knock, and then you're supposed to write back who's there, and you'd be like, yodel who, yodel who, I don't know. And so here's our main loop again, while the user keeps typing things to us. If they ever disconnect, we get a null and it bails. We read one line at a time from the socket. We then process the input, and that actually does the knock knock jokes. Like if you don't say who's there properly, then it's like, no, you got to say who's there, and things like that. So we toss the line from the socket into the thing here, and then that gives us a response. Owl who, owls say who, ha ha ha. And then that line goes right back over the internet. And so we get a line from the internet here. We pass it to our protocol, which actually does the knock knock jokes, and then whatever line we get from that thing there goes right back over the internet. And if we ever get bye from this, then we disconnect. And that's it. That's a multiplayer server. Except it's not really multiplayer because there's no communications between them. Any questions? I think Java's networking is easier to read and understand, honestly. It's not too bad. And one of the nice things about internet stuff is that they don't know if you're using C++ or Java. You can mix and match them however you want. It's up to you. It's still just like more dead silence on the chat. Need more heavy metal music. Okay. So let's look at the boost ASIO stuff and call it a day. Sockets boost. CMU. Okay, so let's see how the standard C++ way of doing it. Boost, we've talked about Boost before, right? Boost is like the minor leagues for the C++ standard library. It's a lot easier to get stuff into Boost than it is into the standard. And oftentimes the standards committee will look at what Boost is doing and be like, yeah, that's pretty cool. And we'll recruit it for the major leagues and put it into the C++ standard library. So Boost has something called ASIO, asynchronous I/O, I think. And it's a pretty cool networking library. I'm not super hyped on it, but it works all right. Let's see. All right. Yeah, they got :hell, just like the C++ standard library. So this is a HTTP client, so it'll connect to a web server and fetch a page, I believe, if I'm remembering properly. Look at that. Look at that. Oh my gosh, it kills me, dude. Look at that. Boost, : ASIO, : IP, : TCP, : IOStream. So, what's cool though about this, despite the dubiousness of the length of the name, is that this is actually going to give you a socket that works just like cin and cout. So I've said before that when you have a socket, you can read to it and write to it like a file. This actually reads and writes to it like a IOStream. Like first week of C++, CSI 40, it's the IOStream class. You can double left arrow into it, and you can double right arrow out of it. Okay. Yeah, so this thing has a timeout set on it. Boost : ASIO : So this gives it a maximum lifespan of 60 seconds, after which it dies. So we are going to connect to the host name with a protocol of HTTP. And path is going to be down here somewhere. Get, okay, there it is. So it's going to get path, host name. So do you see this? So we have a socket, right? We have a socket named S, and basically we've connected to google.com or whatever, and we write to it get in HTML. Have any of you guys actually done web stuff? There's get and there's post, and that's about it. Yeah, so you just double left arrow from writing to the server. So basically, we've got 4 minutes left. So when you send a request like this is a HTTP client, right? You send a get, and you pass in some header files and message body, and let's see if we can pull it up here. Yeah, there we go. Get wiki main page version of HTTP host wikipedia.org, and then we get a response from it, and then that's the header, and then is the body, and that's what Firefox or Edge uses to render a web page. But this is all it looks like, right? And so we're just saying use HTTP 1.0, and yeah. And then so we just write to the socket like double left arrows. Yay, that's cool. Because a lot of people know IOStreams, so why not just make it look like an IOStream? It's cool. And then we read a string from it. Yay! So we just double right arrow out of it. It's like reading from CN. Yay! You just read a string. Works as easy as that. We read the status code. It should be 404. Thing not found. We then get the rest of it into a status message, and it's going to return different status codes, whatever, parses the response headers, and dumps the rest of it to the screen. Okay, so it prints to the screen the rest of the buffer. So let's go ahead and run this HTTP client. We need a server and a path. So let's do www.google.com path / maybe. Response return to status code 302. What path do I need? Dot maybe. Let's look at this get. Oof. Get. Okay. There we go. There. So we just got the DuckDuckGo. I don't know what the hell that is. Something, right? And so we just echo to the web server. Hey man, send us your index, .html, whatever, and then it just dumps the result back to the screen. There you go. Handlebars by wow. Really, it's sending the copyright notice with every HTTP request. That is garbage. That is absolute garbage. That was really not good. This is all minified JavaScript, by the way. This is what minified code looks like. You see how they replaced every variable name with like a single letter, and it's still text though. It does get compressed, but it's still garbage. Our entire web infrastructure is based on. Look at this. It's ridiculous. And so we send that to them, and we got a response. Server is in GNX. Date that, content type JavaScript, content link that, last modified, then connection closed, permissions policy, whatever, content security policy, whatever. And so this is literally just getting all the response back, and then it dumps the web page or whatever it was we asked for, which is a complete block of JavaScript. You asked your CS friend who worked in industry for their opinion on networking. No, I hate networking. It's all gibberish and madness. Can be, but I mean, look, like this is nice, right? Like you just see out things, and, right? Nice, I think. I don't know. Yeah. So you just see out things and seeing things. The only thing you have to be careful for is, again, if you do a CN when the server isn't sending anything to you, you freeze, right? So you just always have to make sure that your reads match the server's writes. Otherwise, you just sit there forever, like I'm waiting, and the server's like, I got nothing to say to you. That's the Boost IO streams library, which I really kind of like for students, and I'm probably going to do more with it in the future. But this is normal Boost ASIO, and so. Create a socket, and look, it looks like Java, right? Host name, that's the port number, by the way. The port number is daytime. That's a standard port number, daytime. And then that creates a socket, and it connects to the host. Host is this one. Look, it looks just like the Java thing, right? So we connect a socket, we create a socket, host name, port. If it failed, die. Otherwise, we get a line from the socket into a string somewhere there, and we echo to the screen, and there we go. So that's Boost ASIO. It's pretty similar. At least to the simplest levels to the Java stuff, it does get kind of gnarly later on. Daytime server.cc. And so it's going to open up a TCP version 4, port 13. It is going to accept connections on that port here. And so it waits for somebody to connect. If an error, no, if not EC, error code. Oh, if there's no error code. If there's no error code, then it echoes to, yeah, it's the same thing. It's the IO stream thing. So it just does double left arrow. It just echoes the current time to the socket, and that's it. So there's a server using boost ASIO. And it just gets now and converts it to something readable. Yeah. So I don't know if this will actually work. Let me see. Daytime server permission denied. Yeah. So let's run this sudo. Sudo needs a fully qualified path name. There we go. Background daytime client needs host name. We'll give it localhost, and there we go. So it gets the current time from the daytime server. Okay, so wonder how complicated it is to get one up and running. So it's weird. Like I've never thought of networking as being that hard. The only annoying thing is, like I said, like if you're doing a read when the other thing hasn't done a write and your thing just freezes, that's the only annoyance to me. Which is why, like on the server, I had it set to timeout. Like if you try doing a read and nothing happens in 2 seconds, it just gives up and just carries on with its life. And I don't know, like it's just never seemed hard to me, because to me, it just mentally, it goes into the same category as IO streams, right? You just write things into it and read things from it, and data comes in over the internet and data goes out over the internet. And the only time it really gets complicated or frustrating is if you have like firewall issues and like the firewall's blocking IPv6 but not IPv4, so it's like, okay, how do I specify this has to take place on IPv4? And like there's some fiddly bits like that. Also, if you're like in a game, what happens if a client hangs, and they're not sending anything to you? Then you have to make sure your server doesn't hang because you're waiting on responses from the client. So there's and people can disconnect at any time. Like that's kind of annoying. Right, like you have a game, you have a quiz show, and you're gonna broadcast things to all the clients, and somebody just disconnects, and you try broadcasting to them, right? Like, does your thing crash because now you have a null pointer there, and so there's some issues that like have to be dealt with, but I've never seen it being that hard. Wouldn't have to listen for tons of stuff like every bullet and ability and stuff. Yeah, we do go into this a bit in IS50. Basically, the server will hold the canonical representation of the world, and every time a client hits fire, it sends a message to the server saying, I'm firing my gun. The server allows it or not allows it. And then it broadcasts to everybody, this person is firing their gun, starting at this point, going this direction. Have at, and the server will know if it hits somebody and decrement their health, and broadcast to them, hey, your health is now 20 or whatever. And there's issues with latency and things like that you have to kind of deal with, but it's not too bad. It's honestly not too bad. Okay, so I'll push out all this demo code to you guys. Like I said, I'm not going to give you guys a networking assignment this year. It was just too painful last year. So all you have to do is the compiler, which is hard, but it's not really that hard. But I would recommend you guys just like look at it and like play with it a little bit. Okay. So that is it for today. On Thursday, we'll maybe go into multi-threading and parallel processing a little bit more. And when it's final, it will be finals week. So I will just open it up for all of finals week, and you can just take it whenever you want to take it. And I'm planning on it being like pretty mild, honestly. So some conceptual questions, converting from binary to hex and float, things like that. you know, the usual. We'll talk about the final on Thursday. Okay. So that is it for today, guys. Hope I exploded your brains a little bit, but it's always good for you. But networking is a big thing. You know, it's a really important thing. So, you know, this year I'm just showing it to you. You don't learn it as well if you don't do it yourself. That's true, but you know, like I said, last year was just a train wreck. So I'm going easy on you guys. All right, peace out.